Let's go. This is Expert Funder and you're watching on YouTube. So let's see today question that we have is 605, right? And can place flowers. So let's read this question. You have a long flower bed, right? And some of the plots are planted and some are not. Okay. So however, flowers cannot be planted in adjacent plots, right? So given an integer flower bed containing zeros and ones, where zero means empty and one means not empty. Okay. So an integer n, you can say return if n new flower, right, can be planted in the flower bed, right, and without violating the, you can say, adjacent no adjacent flower rule, right. Let's suppose we have given here 1, right. So 1 means not empty. Okay, then it is empty, empty, empty. Okay, then it's not empty, right. So if we'll talk about the, if we'll talk about, you can say n, that is 1, right. So there is you can say n new flowers, right, that can be planted. Let's suppose it will put here, right, here, right. So n is a, you can say, new flowers that can be planted in flower bed and without violating new adjacent flower rule. I think you have understood, right? And that's why it's returning true. So now we will see the flower bed example 2, in which we will see n equal to 2. So we have given what? First it is empty, and after that it's not empty, right? Sorry, first is not empty, then it's, you can say, empty, right? And you can say empty, 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 and this is not empty, right? So it is saying n equal to 2. So if we will put here, so it will become what? 0. Now it will become 0, 0, 0, right. And the last, if you put again, it will become 0. So you can see it's violating its adjacent rule, right. It's violating, sorry, it's violating its adjacent rule, right. I'm sorry. Now coming to this one. So this question has been asked in, you can say, uh, in thank question, thank, right. The first we have is, you can say, Facebook have asked, Amazon have asked, you can say Google have asked, Microsoft has asked, right. So these top companies have asked these questions, right. So this is very easy question, but you can say it's not skippable, right. You should have at least one time practice for this question. So what we will do, we will go with the approaches, right, and we'll try to find these outputs, right, it's true or not, right. So what we will do, first of all, in the first solution, what in the approach, what we will do, we'll go with a very simple approach, and in which what we will do, we will scan the, you can say, uh, in a single scan, right, we will try to find the solution, right. So solution would be very simple, and we can find out extra maximum number of flowers, right, that we will count, and it can be, you can say, planted for a given flower bed arrangement. So to do so, we can traverse over all the elements of the flower bed. So what we will do, we will find out those elements which are 0, like empty positions, and for every such element we check if its element, if its both adjacent positions are also empty. So if we can plant a flower at that position, so without violating new adjacent flower rule, what we will do, first, the for the first and the last element, we need no check the previous and the next adjacent uh, flower, okay, position, you can say. So what I'm trying to say, see, we can find what my extra maximum flower, right. What we'll do, we'll take a counter. Okay, we'll take a count, and then what we will do, we'll scan this one, right. So you can say there is what we have containing flower bed, zeros and ones, right? Zero means empty and one means not empty. Okay, so let's suppose of examples. What I'll do, let me remove first. Okay, so we are talking about this one. Let's suppose what we have, one we have, zero, zero, 0 and 1 we have, right? So in this approach, what we should do, we should this is an array, let's suppose, okay, of, you can say flower, you can say flower bed, right? This is our flower bed. So on the flower bed we will try to find what, you can say, extra maximum number of flowers that we can do, right? Let's suppose we will take a count, and this count we will check that how many can be planted for the flower bed arrangement, right? So to do so, right, what we will do, we can traverse over all the element of this flower bed, and we'll find out those elements which are zero, implying an empty position, right? So how many positions we have, right? We have 1, 2 and 3, right? But if we will put after this one, right, after this one means this position, so it is violating, right? It will violate this rule. And if we are not, if we are putting here, right, so it is not violating, so this is good, but this position not good, right? Similarly, if we'll talk about here, if we'll put here, right, so what will happen, it is violating this rule and this rule also, both side. So this is also not good place, right? So the placeable point is only one, this one, right? So we have to say count is 1. Understood? So for every such element, right, we will check if it's both adjacent positions, right, also empty, right? So if so, we can plant a flower, right, at the current position without violating the no adjacent flower rule, right? But we can plant a flower, right, at the position, current position, that is, let's suppose this one, okay, and without violating the no adjacent flower rule, okay. So for the first and the last, right, element, we you can say need not check the, you can say, previous and the next position extra, because see, we know that this position will contain data and this position will contain data. Similarly, you can see here, this position will contain data, this position will contain data, right? This position will contain data, this we have, these two will be remain empty, right? And the rest of the data we have to see, right? So you can say if the count obtained, right, here you can say if this count we will obtain, so we'll check, right, it is greater than or equal to n, right? So the number of flower to be planted, right, if it is greater than or equal to n, so the required number of flowers to be planted, we can plant n number of flowers, right, in a given space, otherwise it will not. That's why if you talk about this n equal to 1, so it is count was what, 1, and it is greater than equal to n, and that satisfy the rule. But if we'll talk about this one, it is not satisfying the rule, that's why it is returning false and this is returning true. I think you have got the answer, right? So what you can do, you can pause this video and you can try your approach, okay? So let's continue now on the browser side and we do implementation. So we are here in the browser section. Let's understand to do the implementation, right? So we have given flower, right, and flower bed and n we have given, right? So what we will do, as I told you, first of all we should use count, right, and this count will take what, we can say value, right, and count number of, you can say, uh, remaining, right? So count remaining, uh, you can say count remaining uh, flowers, right, flowers to uh, store, right? So this is our you can say uh, count, right? So what I'll do, I'll say count remain remaining, count remaining I'll take, and you will understand. Okay, so I'll take minimum, right? Count remaining I will take, and this is nothing with start. Okay, now what we'll do, so we have to find the count first, right? Now we'll take for loop, and we'll go to int I equal to 0, and then we'll start with what I should be less than. We have flower bed, right? So from the flower bed we'll do length, right? So this length function will go from in first index to last index will go, and we'll check if the current flower plot is empty or not, right? So we know that flower we know if flower bed at I equal to what, 0, and we know that this is the position we have to check, right? So what we will check now, we'll check the left and right pots are empty or not, right? So to do that, what we have to do, we have to check boolean, and we'll say left plot, right? We'll check left plot is empty, left plot is empty, yes or no, that we will check, right? And to do that, what we have to do, we'll simply do what we have I, the current index that we are checking, if it equal to what, 0, or what we will do, or you can say the flower bed, right? The flower bed at you can say given position, that I will do -1 for the left position, and we'll check equal to 0. First index should not be equal to 0. If index is equal to 0, I is 0 0, right? It means what, we are at the beginning, is the starting index, right? So starting index, it will always be you can say empty, right? And similarly we'll check the next the given at this given position, at this given position we'll check our left. So left will be where I -1, and we'll check if it is 0. It means what, this is empty, right? So we'll check these two conditions, right? And we'll say left plot is empty. Similarly, what we'll do, will, let me write. Okay, so what I'll do here, I'll write just left in place. I'll write right plot is empty. If it is empty, it will give you the value, right? And to do so, we'll check first. Previously we are checking what, the beginning index, right? First index. Now we'll check the last index. To do the last index, what we have to do, we'll check if I equal to not 0 this time. We'll check what, flower index dot length. So, and we'll do -1, so last index, correct? Now what we'll do, we'll check the, you can say +1, we'll check the right one, right? So this example will remain same, this will remain same, but we will do plus, because we are going to check right one, just that's all. So we will check our left and right. Now what we have to do, we will check if both plots are empty, right? So if both plots are empty, we can plant a flower pot here, right? So to do that, we will check this one that we have already calculated. Let's check both. If the left plot is empty and the right plot is also empty, so I'll just update this one. Right plot is also empty. If both are empty, then we will update our what, flower bed value, right? Flower bed is at this position is nothing but what, I1, correct? And what we'll do, we'll update our count. So that we are talking about, count remaining should be what, not 2 plus plus, direct 2 plus plus, right? Now what we will do, so this is done, right? After coming to this one, right, our for loop is complete, right? So here we'll check, we'll do return, and we'll say the count remaining, how many count is remaining, and if the count is greater than equal to what, given n, then it will say true or false. So let me compile this one. Yeah, it's working. Let me submit this one. So it's working fine. Okay, thank you guys for watching this video. So if we'll talk about the complexity, right, so in the single scan we are going for 0 index to last index, right? Means if we have given the flower bed size is what, n, right? So it will become, time complexity will become what, tc will become O of n. And space complexity we are not studying anything extra, right? So this will remain constant as one. So what we're talking about, let me recap this one, right? So first of all, what we will do, we have given, we have flower bed we have given, and we have given, and so we have to take count, right? So if count is greater than equal to n, right, then we'll say the given n will store into the, we can say, our remaining bed, right? So this number of flower that we have given is enough for to store into the flower bed. And to do that, we have to check our left and right. If both are coming true, empty, both are checking empty. And how we'll check the empty? We'll check this one. At the given index, we'll check left plot is empty and right plot is empty. If both are empty, then we'll check, we'll update the bed as 1, and then we'll say count is remaining. Why we are doing here 1? Because if next time if we'll go with I equal to now 0, from 0 to 1, then we will have some value at the left one. Now this will be left, right? So left plot will have one value, okay? And that's why we will not update this one. So I think we are good now. Thank you guys. Thank you so much for watching this video.